Welcome back, architects. Today we're stepping into the logical layer, the how will this thing actually function stage of architecture. If conceptual architecture is your vision board, logical architecture is when you open up a Google Sheet and start making it real. Logical architecture is about structure, function, and relationships, not yet about technology choices. It describes how the systems will behave, not which tools will do the behaving. This is where we define logical components, services, data flows, integration patterns, responsibility boundaries, integration models, domain responsibilities, as well as non-functional considerations at the logical level. We're not wiring servers. We're not selecting products. We're building the functional skeleton, the architecture before the architecture. At this level, an order management component is just that, a component, not a specific SaaS product or a Java microservice. It exists because the business needs the capability we identified in the conceptual layer. Logical architecture sits squarely in the logical row of Zachman, the row that translates ideas into structures you can validate before any investments are made. If conceptual architecture is the dream, logical architecture is the work. This is where architects and engineers translate intent into structure, answering a critical question: how will we actually do this? At the center of this blueprint is the digital front door, the website and app. From here, responsibilities start to separate. Customer interactions flow into support systems, transactions move into payment and security, and everything connects back to shared customer data. On the left, we see business processes: order, pay, ship. Logical architecture doesn't care where these run yet. It focuses on sequence, responsibility, and flow. What happens first? What depends on what? Where do handoffs occur? On the right, we see data and security concerns. Customer information, product data, and transactions are treated as shared assets, protected, governed, and reused across systems. This is where logical boundaries prevent future chaos. This is the engineer's view. Logical architecture connects business behavior to system architecture without locking us into any infrastructure decisions. This layer prevents the classic enterprise mistake: teams buying tools before they understand what job the tool is actually supposed to do. At the logical level, tools help architects describe structure, relationships, and behavior clearly enough that teams can build from them. Spark's Enterprise Architect is one of the most comprehensive tools for logical architecture. It supports Archimate, UML, and layered models, making it ideal for connecting capabilities, applications, data, and integrations into a single logical view. Now, Ice Panel takes a more modern approach, especially with the C4 model. It's great for showing system context, containers, and interactions, helping teams understand how parts fit together before writing code. And then there's Archi. Archi is a lightweight open source tool built specifically for Archimate. It's simple, focused, and effective for creating clear, logical views without enterprise overhead. And then there's BizDesign. BizDesign is designed for large-scale enterprise environments. It excels at connecting strategy to execution with strong logical modeling capabilities across business, application, and technology layers. Evolution Abacus. Abacus provides deep analytical power. It allows architects to model complex logical architectures and evaluate impact, risk, and dependencies across the enterprise. All right. And then there's Mermaid. Tools like Mermaid let engineers define logical diagrams directly in code, perfect for documentation, version control, and collaboration. Logical architecture is where ideas become executable. And that's logical architecture, the functional layer that keeps us honest before we hit procurement. In the final episode, we take the leap into the concrete world, physical architecture, where servers, cloud platforms, and real-world constraints finally join the party. See you in the finale.